The Master Electrician test is a three-part exam. Firstly, it covers code knowledge, which is a closed book section. Secondly, there are calculations, which is an open book section. Thirdly, it includes practical application, which is also a closed book section. The code knowledge section is often considered the most challenging part of the exam. This is because it covers a wide range of electrical code requirements. Individuals taking the exam must be able to recall and apply these requirements to various scenarios. The calculations section is also challenging, though generally considered less difficult than the code knowledge section. The practical applications section is often viewed as the easiest part of the exam, as it primarily requires demonstrating the ability to perform basic electrical tasks. Overall, the Master Electrician test is a challenging exam. However, it is definitely possible to pass with adequate preparation. With thorough preparation, an individual should be able to pass the exam on their first attempt. Here are some tips for preparing for the Master Electrician test. One should study the electrical code thoroughly, because the code knowledge section is the most challenging part of the exam. Therefore, it is important to ensure one is well versed in the electrical code. Practice calculations diligently. The calculations section, while less difficult than the code knowledge section, still requires the ability to perform basic calculations quickly and accurately. Obtain hands-on experience. The practical application section, though considered the easiest, still benefits from practical experience. This will familiarize individuals with the tasks they will be required to perform. By following these tips, one can significantly improve their preparedness for the Master Electrician test. It's crucial to understand the scope and depth of the National Electrical Code, also known as the NEC. This code serves as the foundation for safe electrical installations and practices. The exam will test your knowledge of various articles and sections within the NEC. These include wiring methods, overcurrent protection, grounding, bonding, and equipment installation. A strong understanding of these areas is essential. When studying the NEC, pay close attention to the definitions and terminology used throughout the code. Understanding the precise meaning of terms like grounded, bonded, ampacity, and voltage drop is critical for correctly interpreting and applying the code requirements. Familiarize yourself with the different types of wiring methods permitted by the NEC. This includes understanding the applications, limitations, and installation requirements for cable types such as non-metallic sheath cable, also known as Type NM, armored cable, also known as Type AC, metal-clad cable, also known as Type MC, and electrical metallic tubing, also known as EMT. The NEC specifies requirements for overcurrent protection to protect electrical systems and equipment from overloads and short circuits. Understand how to select the appropriate size of circuit breakers and fuses based on the ampacity of the conductors they protect. Also, familiarize yourself with the requirements for ground fault circuit interrupters, also known as GFCIs, and arc fault circuit interrupters, also known as FSIs, which are designed to protect against electrical shock and fire hazards. Grounding and bonding are critical for ensuring electrical safety. Understand the purpose of grounding and bonding systems, and how they work to provide a low impedance path for fault current to return to the source. Study the NEC requirements for grounding electrodes, grounding conductors, bonding jumpers, and equipment grounding conductors. The NEC contains specific requirements for the installation of various types of electrical equipment, including panel boards, transformers, motors, and lighting fixtures. Familiarize yourself with these requirements, paying attention to issues such as working clearances, ventilation, and protection from physical damage. The calculations portion of the Master Electrician exam will test your ability to apply electrical formulas and principles to solve practical problems. Be prepared to perform calculations related to Ohm's law, power, voltage drop, conductor sizing, and transformer sizing. Ohm's law describes the relationship between voltage, current, and resistance in an electrical circuit. Understand the formulas for calculating voltage, current, resistance, and power using Ohm's law. Power is the rate at which electrical energy is used or dissipated in a circuit. Be able to calculate power in both direct current, also known as DC, and alternating current, also known as AC, circuits using the appropriate formulas. Voltage drop occurs when voltage is lost as current flows through a conductor. Understand how to calculate voltage drop in a circuit and how to select conductors of the appropriate size to minimize voltage drop. The NEC specifies requirements for the minimum size of conductors based on their ampacity and the anticipated load. Be able to use NEC tables to determine the appropriate conductor size for different applications. Transformers are used to step up or step down voltage levels in electrical systems. Understand how to calculate the primary and secondary currents and voltages of a transformer, and how to select a transformer of the appropriate size for a given application. The practical application section of the Master Electrician exam will assess your ability to perform common electrical tasks safely and correctly. Be prepared to demonstrate your skills in areas such as wiring circuits, installing devices, and troubleshooting problems. Practice wiring various types of electrical circuits, including lighting circuits, receptacle circuits, and switch circuits. Pay attention to proper wiring techniques, such as making secure connections and using the correct wire sizes and colors. Be able to install common electrical devices, such as receptacles, switches, lighting fixtures, and circuit breakers. Follow the manufacturer's instructions and the NEC requirements for installing these devices correctly. Be prepared to troubleshoot common electrical problems such as open circuits, short circuits, and ground faults. Use a multimeter to measure voltage, current, and resistance to diagnose the problem and identify the cause. In addition to technical knowledge, the Master Electrician exam will also assess your understanding of safety practices and procedures. Be sure to follow all safety rules and regulations when working with electricity. Always de-energize circuits before working on them. Use appropriate personal protective equipment, also known as PP, such as safety glasses, gloves, and insulated tools. Be aware of potential hazards, such as electrical shock, arc flash, and explosions. Familiarize yourself with the NEC requirements for safe work practices, such as lockout/tagout procedures and the use of ground fault circuit interrupters. Effective time management is crucial during the Master Electrician exam. Pace yourself wisely and allocate sufficient time for each section of the exam. Read each question carefully and make sure you understand what is being asked before attempting to answer it. If you are unsure of the answer to a question, skip it and come back to it later if you have time. Answer the easier questions first to build your confidence and momentum. Double-check your answers before submitting the exam to ensure that you have not made any careless errors. The code knowledge portion of the exam requires a deep understanding of the National Electrical Code. Firstly, familiarize yourself with the structure and organization of the NEC, including its chapters, articles, and sections. Secondly, focus on key articles related to general wiring requirements, such as Article 110, requirements for electrical installations, Article 210, branch circuits, and Article 215, feeders. Thirdly, understand the requirements for overcurrent protection as outlined in Article 240, including circuit breakers, fuses, and coordination. Fourthly, study grounding and bonding requirements detailed in Article 250, which covers system grounding, equipment grounding, and bonding methods. Fifthly, become proficient in conductor requirements, including ampacity, insulation types, and sizing, as covered in Article 310. Sixthly, review wiring methods and materials such as cables, raceways, and enclosures, as specified in Chapter 3. Seventhly, pay attention to equipment installation requirements for various types of electrical equipment, including transformers, motors, and generators found in Chapter 4. Eighthly, understand special occupancies and equipment, such as hazardous locations, healthcare facilities, and swimming pools, as covered in Chapters 5, 6, and 7. Ninthly, familiarize yourself with tables and examples in the NEC that provide guidance on calculations and applications of code requirements. Tenthly, regularly review and update your knowledge of the NEC as new editions are released, noting any changes or revisions to the code. For the calculations portion, firstly, review basic electrical theory and formulas, including Ohm's law, power calculations, and voltage drop calculations. Secondly, practice calculating circuit loads for various types of electrical equipment, such as lighting, receptacles, and motors. Thirdly, understand how to size conductors based on ampacity, voltage drop, and other factors, using NEC tables and formulas. Fourthly, be able to calculate overcurrent protection requirements for conductors and equipment, including circuit breakers and fuses. Fifthly, learn how to calculate transformer sizing and protection requirements, taking into account primary and secondary voltages and currents. Sixthly, practice calculating grounding and bonding conductor sizes based on fault current and equipment grounding requirements. Seventhly, familiarize yourself with power factor correction techniques and calculations to improve energy efficiency. Eighthly, understand how to calculate short-circuit currents and perform coordination studies to ensure proper system protection. Ninthly, review voltage drop calculations for branch circuits and feeders to maintain voltage within acceptable limits. Tenthly, use online calculators and software tools to verify your calculations and improve your accuracy and speed. For the practical application portion, firstly, gain hands-on experience working with electrical tools and equipment, such as multimeters, wire strippers, and conduit benders. Secondly, practice wiring circuits for various types of electrical equipment, including lighting, receptacles, and switches. Thirdly, learn how to install and terminate conductors in electrical panels, junction boxes, and other enclosures. Fourthly, become proficient in troubleshooting electrical circuits and equipment, using diagnostic tools and techniques. Fifthly, understand how to perform electrical testing and measurements, such as voltage, current, and resistance tests. Sixthly, familiarize yourself with safety procedures and practices for working with electricity, including lockout/tagout procedures and personal protective equipment. Seventhly, practice reading and interpreting electrical drawings and diagrams, including single-line diagrams and wiring schematics. Eighthly, learn how to use the NEC to find information and guidance on specific installation requirements. Ninthly, participate in electrical apprenticeship programs or training courses to gain practical experience and knowledge. Tenthly, seek mentorship from experienced electricians and electrical contractors to learn from their expertise and best practices.